Hello, everyone. Welcome, welcome. Oh, we're finally getting back to our coding project today. Should be interesting. I've spread some catnip for the kitty, so Ember is a little bit more wired than normal. Yeah. Ember and Sky are the type that will just, like, straight up eat the catnip that's laid out. You know, not roll in it necessarily. They will take some time to just straight up eat it. So you get to see how it hits each of them individually. But yeah, game project today. Let's get that down a little bit there. We're gonna be doing some retrospective work. We're gonna be looking at our code base and figuring out what kind of stuff we need to do to make adjustments, and what kind of adjustments those might be. But yeah, hey there, Key. Welcome. We're still not on schedule for the week, but we're better than some other weeks. Figure if I can get schedule, lined up again, we can start working on the next steps. But good time. Let's check in where we got the kitties. Ember has run off. Molly is down in her bed. Sky is on the table side there. I am going to need to come up with some, or refresh the adhesive for that heating pad. Oh. Ember just came flying in from the side, from the top of the play area camera. You couldn't hear it, but she slammed into that TV screen. There is something on it that she wanted to be dead right now. She is now perched above the TV, looking down upon it. Oh, but let's see. The siblings and Sammy are up on the bed there, being all cozy. Okie dokie, though. So like I said, a decent portion of the stream today is going to be looking back at what we done and why we done it and what we gonna do. I do have Godot open just for practical purposes at the moment, but again, for reference, there are... Oh, hey there, Laura. Welcome. We are just getting going. But like I've said, for reference, this is all that's in Godot. Well, okay. This object right here, this core node and its attached script, core.cs, and default startup resource. Those are the Godot things. Everything else is handled on the C# side as far as the code infrastructure. We don't have really any GD script. There's not much of anything else, with some caveats. But let's start there. Yeah, the caveats are really what we're getting to during this, is figuring out what needs to be a different thing and what doesn't. So we start with our core object. So let's close everything here. Hey, sharpshooter. Let's see if you can remember their names. Come here. Come here. Oof. Okay, where do I got that? It's one of the ones that lurks in an odd place because of the folder structure. There we go. You're gonna run out of ellipses there, really. Or is it Riley? Hard to say. I'm going to guess Riley with your K-pop Demon Hunters handle. No, on the screen we have Sherbet, Mason, and Sammy currently, clockwise. What is happening here? You are currently looking at three cats, a Visual Studio IDE showing C# code using Godot, and then me, based on which stream you're looking through. Yes. In particular, we're looking at... I have not. I have indeed not seen your guess the cat names in a bit there, sharpshooter. But no. Again, clockwise, starting with top left is Sherbet, then Mason, then Sammy. So this is our actual appropriately named core node. This is what Godot starts with. And it's really just this scene. We'll get to that in a moment. We don't have anything in the constructor. You and you and you. This is also going to be our opportunity to look for things where we can start adding in some testing. Okay. So ready fires when all child nodes have been added to the tree. Let me oh, it's unfortunate. I need a screen cap. I think Okami is actually going to be streaming or is streaming Pal World right now. I am taking a screen cap of that comment because I'm sure we will all find it hilarious. That's fine, Riley. A lot of people do come in and just lurk. That is your privilege and prerogative. So if you choose to watch, I hope you have fun listening. Just one moment. I'm saving a screen cap. Windows, why you gotta be bad at windowsing? Why you gotta be bad at windowsing? You had one job. Oh yeah, that's going to be a ton of fun later. The cats that are on the screen currently are Sherbet, Mason, and Sammy. Top left going clockwise. Sherbet and Mason are brothers, and then Sammy is the tuxedo. Okay. So again, ready fires when let's just do it here. We have core, which extends node. is our main Godot scene. In ready, we are going to accidentally close that, which is going to potentially result in, despite me telling it not to, it trying to update. Let's see if it does. Oh, no, okay, it actually listened to me. That's fantastic. Okay. Have our ready, and so this is once Godot has loaded it into existence. The Godot ready process is to say each individual element of a scene is ready once all of its children are ready, and once it is part of a tree. So in the case of core here, once these two objects are done loading, essentially, so all of their child objects are done and they are now added to the tree, they are part of core, they get their ready. And then that ready, once all of those children are done, it propagates up to the next parent, into the next parent. It's all of your constituent elements are ready to go, is what ready means. Thanks for swinging through, Riley. So we get that. What we're going to do is we're going to take that resource file, this little guy right here, which gives us like what's our scaling factor, how many frames per second are we trying to get, that kind of thing, in order to, well, we're prepping a bunch of our variables, let's call it. This is going to be one of the things I want to look hard at, because while there are useful bits to it, a lot of it is something that we moved away from. This used to be much larger, and I've been slowly pulling parts out of it. While I do want to make it so that it is possible for me to have this sort of structure, it is not... This is not any... This does not suit any of my purposes, I think my large-scale purposes. So this is something that I would have to make at dev time. It is part of the development process. So it doesn't lead down the road of things like modability, really, extensibility, any more than the other structure that I have started using, and that's the sort of service model that we've got, where we are registering different things to run. We could still do that and accomplish everything that this does. There are variables that this lets me tweak, but I can do that in like a constants file somewhere. So the first thing we do is parse that file. It is specified when we run it. Where is that placed? Tools. Well, here we go. This is the default path. It looks for that default file. If you get a different one, it will use a different one. This is another reason that I'd like to get rid of it, is it removes having to parse this thing. I'm fine with having command line arguments, but I would like them to be to not be part of the actual core load up, or assumed to be present as part of the core load up. So we do that, and then we're going to initialize our services. So let's see here. Okay, so now we're going to go into services initialize, and in that, we are getting our, we've got our resource loader load here. We're getting that part in. So if we go into our definition here, we have that resource file present, and all we're doing with it is setting it. We don't really care about this portion. But this makes it a good candidate for being removed. Because that's all that's happening here is we're saying, what is our resource file? Okay, so then we are going to go to loading screen. And during the loading screen, we go into the resource and we're finding the loading screen, which is... This is why I said with caveats as far as the what the objects were, because most of these, I don't really need them to be Godot scenes. It doesn't hurt or really help too much for them to be Godot scenes. There's some ease of construction going on here, so we're probably going to leave them that way. But doing that means that the resource file stays useful. Kind of, we're juggling things a little bit. So let's see here. Where are you hiding? Screens loading. So all loading is it has a progress bar that doesn't do anything currently. But that's all it does code-wise. Screens loading. I'm sorry, visually wise. So this is a one-time operation during ready. We are going to go in and execute this. I don't actually need the if not started. Don't even know why this is async anymore. Is that always async? Yeah, weird. Oh, it's flagged as async because there's an async operation happening in it. Silly me. But it's async in that there is an async operation happening, but we're still handling this synchronously. We have started because we don't want to be able to enter this multiple times, since technically you can trigger another instance of this scene could be instantiated. We don't want this to happen again. So we're going to do our load catalog task. We're prepping that. And we're creating a list of tasks where it will be run this function. Here is the list, the list. And then we're going to say once all of those tasks are done. This is just the one task currently, but there's nothing stopping me in this kind of pattern from having multiple of them. So what we're doing here is so this is reading in the catalog data. This is we have an async wait happening here for the catalog to be loaded. Right here, await catalog.load, which is set up in our services. If we go to our services, then the first time anybody mentions services, this is when stuff starts to happen in that regard. So as soon as this class is invoked, the first time anywhere in the code we say services dot, we're going to go through and we're going to execute this whole block here. Does this potentially need to be done differently? yes, this is territory that might need to change. Because... Actually, no, this should have happened before, because we set this. Yeah. We set this earlier, so it's not at this point. In theory, it is... Ember, 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 Ember. So this load configure services that we have here. Services initialize, where we extract that startup resource type from this. Services initialize, all that's doing is making this call here where we set startup resource. By invoking that, we instantiate it, and all of this is going to happen. It's the core node. Ember. It says, you are not giving me sufficient pets and cuddles. I am going to get in your face. She is just purring away. Someday I will figure out a good mechanism for having a microphone I can put up to the cats so you can hear them purr when they do this. The trick is, not also deafening you with all of the surrounding noise that happens. That is filtered by both the noise filtering for you and the headphones for me. Okay, so we're registering all of the services during this process. So these are all of the... Almost all of these used to be part of that resource file. This is a reason that I want to be getting rid of the resource file. And for the most part, I can. Some of these objects are still going to be, if I recall, nodes, which will let me instantiate them. So I think the collision manager is still a node. Render visuals. Yeah. So this is physics server-based collision manager. We don't do that one anymore. So this doesn't really need to exist. We can set up other things that are scenes. We could even have some definition of them here if we need to. We don't really want them to be packed scenes if we can avoid it. But they can be. They can be. We could make parts of that. Classes that invoke them and the like. We'll see. Okay. We set all of these up. This is everything that does everything here. We have our catalog type. This is the thing that loads in all of our data files, all of the JSON and similar that composes the objects in the game. This is... I don't know if we're still going to need this. This is our access to a local rendering device. I had hoped this would get us a more uniform way to access some compute shaders, but the way it's set up, we don't really want to use it that way. Just the compute shaders in general have a flaw in properly utilizing them that I'm not sure how to overcome. Hopefully we'll get there. Ah, okay. This is another part of the compute shader logic. This was having a centralized location for a particular buffer. Again, these two pieces here. I will describe this in a moment, just get my thought in text. Okay. So these were created as part of a efficiency improvement attempt. So we thought, hey, we could just have a core local rendering device and we could keep track of that. Problem is, each local rendering device has all of the elements of a compute shader local to it. I get that local rendering device, I set up buffers with it, I set up a shader with it, and then I will execute everything with that entity. Any deviation from that can lead to problems. Whether because I don't have access to that object, if I set up a shader in one, it's not elsewhere. If I set up a buffer with one, it's not elsewhere. So any sort of efficiency I'm getting from potentially having these things stored somewhere is lost if I need to have multiple of them anyway. So these are not terribly useful to me currently. They are on the chopping block then. Next up, we have something that is really meant to be a kind of an in-house sort of tool, a code or a development time kind of tool. And this is something that is, well, also for like first execution of a mod kind of thing. This is going to... Actually, I think this one... This is why we're doing this. One, I've been looking away from it for long enough that I'm forgetting stuff. Yeah. Okay, so here's our flow generator. This is for map navigation. What we did with this thing was to go in and say, one, it generates an image that acts as an inward pull. So if I center that image on the screen or over top of, say, the player, I'm supplied with a series of vectors that tell any entity this is the vector to move in to reach the player. It is... it is slightly cheaper to reference a position in this 2D array than it is to constantly say, where am I, where is the player, draw a vector between them, get the unit vector. And while that's not a massively expensive algorithm, it is happening a lot. So mitigating that is useful. The second thing it does is translate screen images, like a floor plan, into a similar flow that essentially pushes enemies away from walls. Combining the two creates sort of a gravitation towards the player that will also avoid walls. Okay, so Entity Manager is the thing that controls all the entities. Entities in this project are all bullets, opponents, pickups, everything. This is like, I mean, in the old bulletin board era, this is an object. It covers mobile objects. It covers the player. It covers everything. So if it's a thing you can interact with in the game, it is an entity, and the entity manager is the thing that drives the creation and removal of them. So we are loading the catalog. So we have that. We have our flow generators. Flow generators need to be cleaned up. Dealing with the compute shaders is a critical thing to address currently because it is terribly useful what they are giving us. They are giving us wildly fast brute force algorithms for things so that we don't have to deal with the performance overhead of default Godot physics. But it's a brute force algorithm, and if we try to handle it just directly in code, it's extra slow. So we don't gain anything over the Godot physics. If we move it to the GPU, we can very much gain. But the processing time of that is becoming a problem as well. We need to figure out a way to balance that and to perform the whole operation efficiently. Can we do that? Remains to be seen. We may end up falling back once we assess our goals again. So then we have player world inventory. Okay, so entity manager, all entities. These are which ones still exist, which ones are to be added, which ones are to be removed. It also will handle, well, it's to remove them, to add them, that kind of thing, which ones are out there. The player is the player services are kind of a wrapper around the player entity. There is an entity in the entity manager that is the player. It is, for the most part, the first one to come into existence. With some wiggle there. I mean, the world may come into existence as, like, world objects might come into existence first. But the player comes into existence, and we track that using the player state. We track the player's inventory and how we show their inventory. The world is the map and any sort of events related to it, any sort of structures related to it. So where are we and where are we going kind of stuff, which rooms are active. Then, so we have the game screen here. Where are we? Yeah. So game state is the relevant one. If I want an object that is explicitly a game object, I can get that here, but what we really want is to interact with it as a game state. This is a cleanup here. So flow, then we have entity, player, world. Player world, then we have so this interface model. Let's just check this out here. Get this file savable so that I can compulsively save repeatedly as I need to. There we go. So we don't want to refer to the game object. We want to refer to it as its interface. There is a wrinkle there because the game object is a scene currently. Again, it doesn't really need to be. So these are game level messages. We have interfaces for the things that emit these messages. There are core objects that emit the messages. When something wants to know, has a game start step happened? It subscribes to this. It listens to this object. It does not listen to any particular object. It goes to whatever the services say is the start step emitter. In this case, the game state object, this thing, is the same object. We actually have like a single entity here. We say, if I need a game object, it is a game object. And then when it's game state, I say, get me that game object. Start step, time pass those, same object. That same thing is the one that emits those messages. These interfaces say they can be told to emit that message, and they emit that message. So then we proceed into collision handling, which is here we have what is our physics state. We emit messages. Those are the collision manager. So here is world state here. Oh. Interesting. I had a duplicate here. Just make sure that was actually a duplicate. Yes, it was. I don't know what that actually would have done, but anyhow. So we're setting up what our world state is. Say game scene. Messages. So the game is the actual game. Like if you were to... Once we are to the point that you have like clicked start at the main menu, you are now in the game. So all of the interactions from there. Once we move along a little further, there's likely to be more intermediaries there. The world is once you are into gameplay. So I'm on a map. I have enemies moving around. I have the player moving around. That is world state. Six messages. So the entity added emitter showing up this late is interesting. That should be up with you. So this is currently a core entity added emitter, but the only thing that should ever be adding entities is the entity manager. So that's something that we'll need to look back at. We have some convolution here. We have the terminology of levels. I don't know if we're still doing that. Okay, so we have passage, room, and level messages. So this creates our service provider. We don't have one yet. We have created it by the end of this. This does not save us, so let's see here. This static should only ever happen once. That should be okay. It's kind of redundant, but make sure I didn't blow anything up by shuffling some of those lines around. Still runs, things still move. Okay. So we're looking at, again, we're considering how all of this stuff needs to work for us to consider it good enough, that it is doing what it is supposed to do. This basic movement that we saw there, that's where we want to be in a lot of ways. But there are definitely flaws in this logic as it currently stands. Let's Like, performance-wise, we're currently fine. But that's here nor there. It's, we want to figure out what amount of things on the screen, what types of behaviors we still need to fill in. All of that stuff needs to be accounted for in order for us to be able to get this all cleanly in. And that's what we're starting today, is we're going to be going through the code base. We're going to be figuring out what do we have, what is good and what isn't. I want to get that baseline as best I can so that I can then proceed into making some early adjustments with an eye towards the sort of stuff we're going to be ripping up. We will be getting to some of the bigger targets very shortly once we hit the actual core loop of the game. Just a moment here. Cute. Okay. So this is a prime example of what we're dealing with here. The level messages, it's, I don't remember what those are for. It's not just that I don't recall specifically exactly what I was doing with them because we've stepped away. It is, what were those even for at this point? Because I know we have some accretion in here. We have some things that put it in, made some adjustments, and that code kind of looped around or no longer needed that old code, but it's still there. Those in particular, we need to find and stomp them out quick. Vestigial code is a real danger surface when it comes to a code base. Hey there, Pomegranate. Good to see you. You are currently making a design with a dodecagram. What would a dodecagram be, since... I mean... What does 20 have to do with it? It said, like, dodecagon. The dodeca part. 20. Oh, no, okay, I see 12. Yes. Yes, 2 and 10, I'm sorry. What does 12 have to do with it? Get our level messages. So we have those loaded. We have our service provider. Anything that's asking for you? I do. The link tree in the video descriptions and in the bio on Twitch, I believe, should have a link to the Discord, Pomegranate. There is actually a board for, like, dev talk. Let me me verify. I've let myself fall behind on some of the Twitch infrastructure stuff that probably needs to change, you know? Okay. The bio on Twitch, in desktop mode, there should be an about, and on the right-hand side of that, in a super intuitive and easy to find way, is a little text that says LinkTree, which is actually a link that will take you to the list of links. I use that because a lot of the platforms only give you so many links, and you often have more links than they give you links for. Someday I'll make use of my webpage. For now, I have a domain. Okay. So this gives us our service providers. We're all set there. Our game services preparation. So we have our entity renderer, but is there anything on the entity renderer that we actually need? Well, we'll get to those. We'll be getting to those soon enough. Okay. So we went through core, we went through our loading screen. On our loading screen, so as soon as we did this, all of that initialization happened. So we configure the services. There is a dev board, a dev chatter board if you want, if it is like software development or something related. Otherwise, there's just there's the main page and silly sticky notes, depending on whether it's something serious or a joke. If you are, there's one for everything's thematic, so that might be a problem. If it's a sketch on paper, there is one for like posters and such, artistic expression and what have you. We configure the services. Let me take a quick look here. This and then this. Oh. Okay. I see. I see. Bit runic. I see what we're going with dodecagram. Okay, so we load through the services. Is it like Liam? Is that what it is? Either way, hello, welcome. So we load our services. I used to be able to recite the Elder Futhark, but I can't anymore. Used to be able to recite the major arcana, never learned the minor arcana for, can't remember which tarot that I learned. It's one of the fun ones. People say tarot, but tarot is not just one set of cards. There's like a lot of different versions of them and different cards and names to them kind of stuff. So we load the loading screen. Loading screen is our... where we're actually reading in the catalog data. We're waiting for that to happen. We don't have an indication that it's done. This just completes is what's happening here. Yeah. Well, not in this. This part is irrelevant now. Because what we're saying is run this task, do load catalog, wait until it's done. Once we have reached this point in code, that means it was done, and we raise the corresponding event. Okay. We are doing a lot of code. There is a lot of technical stuff flowing by. A lot of what's happening is me just reminding myself what is happening, as well as making minor adjustments as it goes along. I may get distracted, but this does mean that we have plenty of time for chat and questions if and when they appear. And we're probably going to be doing this for at least a few streams of coding. There are some targets that I want to get to that are effort expensive. But they're really only viable if I approach them with some care. It's this early part in the core loop that we're going to be heading into shortly that are some of the early potential win areas for how we can start refining this. We've been focusing a lot prior to this on kind of micro optimization in the physics side. So in the entity to entity interaction and kind of time slice by time slice actions, that we have tightened things down, but while we could continue trying to get the shaders just so that everything is working how I think it should be, that is, we're doing some sorcery. The dark rituals are happening in order to get what we're doing working. And I don't want to hyper optimize in that territory if there are other places that we can make things run more cleanly first. Or at least I want to stop doing that because that's what we've been doing. Instead, we're going to be going through the load up sequence and that core loop, identify things that are either that might need improvement, that might need removal, that are candidates for adjustment in our new targets, let alone identify those new targets. One good example of like setting targets, let's actually do a bit of that for just a moment. So I start the game. We have a little sprite here. We have the character sprite. Character sprite is 32 by 32. The blobs are about 16 by 16. The screen's resolution is effectively 1080p with a zoom factor of 3. So every pixel, first we're already scaled up for it to be 1080p, then we're scaling it up by a factor of 3. So every pixel is a 3 by 3 within that already scaled up perspective here. We can see one of the problems of our map controls. Some things slipped through the wall. That's not out of the question, but we do need to fix that eventually. So part of it is, how many things do I care about being on the screen at once? And we can do some quick math on that in a moment. Okay. So hypothetically, if I were to take the player model and tile it across the whole screen, no overlap, there's probably going to be some pixel, like they're going to be close in some spots during the animations. But if we were to tile it across the screen, we'd be looking at, let's say, 1050 things on screen. Then let's say I have a bullet for each one of them. So one of the little mouse projectiles for each one of them. That's going to give me 2,000 things. So the question becomes, if I were to fill the screen with that many things, if I have 2,000 things present at all times, what does that look like, and is that enough for our purposes? Because that does inform a lot of what we're doing. This isn't a perfect indication of what 2,000 things looks like, because there will be some delay in here. I would need to randomize them a bit. Yeah, that'll do. We don't need the delay if we just add the randomization. So this is part of our cost surface here. This is about 1,800 things. They're tightly packed. They shouldn't be tightly packed, or at least they should be based on the current logic, but in actual gameplay, they would not be. Okay, we're at about 23. Can we get, can we hit the right territory here? The fact that this one's alive is an indication of one of the bugs that we have in our current collision logic. So at about 8 to 900 things, we have more than enough FPS. We're sitting at like 100 with this many entities active at once. So again, 8 to 900 things. If I triple that again, yeah, let's do that. That'll put us up there. it's fiddly. I could have things like have doubles instead of triples and make it a little easier, but... Okay, so here's about 2,400 things. We're getting about 40 frames a second, which is in the acceptable range, but I would really like to have more than that for optimal. I'd prefer to have over 60 in kind of like maximum throughput when we're operating within spec. If we exceed it, I'm fine with it going downward. It just should not break the game. So all physics should still happen. It's fine for it to go slower to account for it, though. So let's say... Let's actually get a note in here for that. Okay, if we say a broad target is I want to be able to have at least 2,000 things on screen. We'll say equal to. If I can say at 2,000, I'm still getting 60 frames a second, then we're in good shape. If we can't get 60 frames a second at 2,000, then we want optimization. That's going to be our new target. Prior target was verging on 5 digits. I want to set the target lower this time and say, if I can hold here and it dips down, after that point, it's okay. Because aside from projectiles, like our little wind-up mice here, we should not be getting this level of overlap. We're rendering at 39 frames a second, by the way. This is another thing that I want to be able to handle for performance purposes, is I want to also know what the world frame per second is. Because the world will not let the game run any slower or faster than if it was running at 30 frames per second. So everything is in terms of there are... Whenever something moves, it moves as if it were doing that sort of movement 30 times a second. If the processing makes it so that it could only move 15 times a second based on real-world clock time, the distance on the screen and the pace at which it crosses the screen per, like, animation cycle kind of stuff should remain the same, or at least... the rate at which it moves is based on the world tick, not on the computer tick or, you know, the outside clock tick. If there was a clock in the game, it would move in fixed steps, no matter how slow or fast the game is going. Whenever it updated, it would always be exactly this much. I don't have a good way to represent that. But right now, with 2,400 things, which is over target, so it's okay that it drops, we're down at 40, which means it's going to be kind of narrow as far as where we are getting with some of these. We're going to cut it back just a little bit and see if I can still get an impression here. Yeah, there's a pretty tangible difference here. Like, that is a drastic shift. We have a, I would say, a greater than linear cost. Because at 800, I'm getting about, let's say 90 frames a second. One would assume that I could get... actually, we're pretty linear given this number. But these are metrics that we want to look at. But so what we're saying here is this is going to be our target. It's as far as the feel of the game, mechanical feel of the game. I want to be able to have 2,000 things on the screen without dropping below 60 frames a second. If I can get that, then that's a good baseline. Some things are going to be more expensive than others. Some of the things might be really complex objects. That comes down to level design and art design and similar. But this is our goal. We have something to shoot for here. We're scaling it back. Part of that is because we have the idea of rooms now. We are going to have the idea of you arrive in the room, there are enemies that appear in the room, clear the enemies, move to the next room. Whether this ends up being a full, like, side-scrolling beat-em-up kind of thing, where there are, a true fixed series of enemies that appear, move towards you, and you clear them. Whether we do, like, old Zelda / Binding of Isaac kind of pattern where rooms contain enemies and sometimes you can immediately leave the room or you have to clear the room to proceed, that kind of thing. And you can, leave and return to rooms that you've already cleared kind of stuff. That's currently not on target. What we have is the idea of you enter the room, enemies are present. Enter the room, defeat enemies, move to another room. That's our basic flow here. And the assumption is entities, which is on the screen at any given time, we want to be able to handle 2,000. We aren't going to say we are targeting 2,000 because that's a lot. We also are not saying that when we present the screen here, that we're talking about the entire screen would be the area that the enemies fill. Because this black Swiss cheese looking thing that I'm standing in is effectively a room. That is where the enemies would be, and they would be non-overlapping, so they would all be restricted to that space. So likely when we're actually presenting it, there is going to be a little bit of dead space around the edges, usually representing walls, exterior walls, same as on the sides. There might be some extra space devoted on the top or on the bottom or similar to fixed user interface, your classic Diablo or PoE location for health bubbles or inventory or icons or anything. Maybe there's some indicator of the inventory that when it's not on screen, that kind of stuff. So it's not just going to be, oh, that's why. This isn't an enemy. I forgot about that. That's a spawner. That's the thing that made these enemies appear. Okay, but with all of that described, we're going to take a quick break and I will be right back. Okay. Back to documenting. And bear in mind, this isn't documenting like I'm writing what I'm filling in blanks so that people know what's going on necessarily. Not to say that that is in any way bad. The goal here is to actually identify what we're doing, why, and if that's an area that we want to change. Okay, so we've read the catalog data at that stage. We went through loading, so we loading here. Now, this one is going to say that loading is done. So this is all the way back up here in the core loop that says when loading is done, we're going to do a thing. Welcome back, Riley. Right here. So when we load the loading screen, we are saying, okay, we get a loading page, we subscribe to the event on it, and we attach that as a child of the core node. It becomes a visible screen. Then, once we get this message back, we're going to call this and say, if loading is still present, we are going to remove that event. This is actually... the fact that we got here is interesting. But anyway, we remove the child, we get rid of it, we clear it, all of that. So we are now back around here. We have completed that part of the load. Remove the loading screen. Okay, we remove the loading screen, we load the main menu. This is part of what I'm looking into. Is I kind of want to move to a state machine model here, where instead of it being this is kind of an esoteric sequence, in that at this stage we're on loading screen. When loading screen is done message happens, we are then going to say, okay, switch to the main menu. We're technically doing a bit of a state machine here in that we have these sort of handoffs, but we're not in a state. We are in a sequence of events kind of thing. Nowhere is it I am on the main menu. As far as the code logic is concerned, it's that menu is present and I am subscribed to that event. There is some potential nuance to that makes it so that it's harder to recover if something goes wrong. To put another way, once I have loaded the loading screen, I am waiting for loading to be done. Since I'm not in a state that says we are currently loading, there isn't a place for logic that says, hey, loading should be happening, why isn't it done yet? Kind of stuff. While you can't always predict how long these things will take, you can look at it and say, we've been loading for an awful long time, something is wrong. That sort of thing. It also gives you a way to kind of unwind everything that you have been doing, like where you are. So it facilitates things that are more easy, like dropping backwards through menus. Go back to the prior menu is easier when you might have stacked states, where it is go back is just, okay, end this state and go back to the prior one. End this state, go back to the prior one. But we don't currently have that. So we load the main menu. So we're going to get our main menu object. We're going to get the start game and shutdown messages connected, and we're going to attach that. Similarly, we have an unload main menu that does the opposite of that. Shutdown is just get rid of the whole game. Get tree quit ends the Godot program. Yeah. So on start game is I press the button, which will take us into the game screen. We get rid of the main menu, we load the game screen. Similarly with the game screen. So we have a bunch of add them, remove them. We're not going to touch on, we're not going to focus on the, like, what is happening in each of these, because if I make major changes to some of the structure elsewhere where we're more interested here, it will splash into those, but I'm not going to make a change in those that would do the opposite. Like, I'm not just going to change how I load the main menu, I'm going to change how I load screens. And then the main menu can have exceptions, but I'm not going to make it so I'm not going to change the loading screen because I changed the main menu. We're looking at something a little more structural for our changes right now. But in relevant sense here, we are going to load the game. Okay. When we load the game, this is a service scope begins. This is relevant. And then later we're gonna service scope. This is something that I have learned over the course of this. We learn a lot of things. Some of them perhaps we were not meant to know. So all the way up here I have add singleton, add singleton. What these are is these are truly universals. That is, for the entire runtime of the program, there is and shall only ever be this catalog object. If you ask for it, this is the one you're getting every time. Same with this local rendering device manager, but that's not a good example because this should not be. But all of these others are add scoped. When they're scoped, it's when I ask for that thing, I will get that specific thing over and over every time I ask for it. So if I ask for an entity position buffer once the game has started, I will get that one. But if I end the game and then start the game again, so for example, as of right now, the catalog exists, and that catalog is universal. It will still exist. It is the same one. As soon as I do this local rendering device, this entity position buffer, it exists now and is being used. But if I do that, it now has ceased to exist, and now it's a new one. This is true for everything in add scoped here. Did I do this right for all of them? Should I be doing that for all of them? That's a future new question. But this is relevant because anything that we call scoped, that's where we are. Say, that's where we live. Is we are within a scope at that point. So we should be wrangling our services accordingly. Okay, so we start the game, we have the game object. As soon as we add child to it, now we're going to jump into the game class here, which I must find. It lives in this general vicinity somewhere. There you are. Game. So we have our initialize, we set up our RNG, we could move this elsewhere. Number generator. We set the fixed tick rate. So here's our random number generator. This is our fixed, we're naming the node. This is Godot infrastructure. We're setting our fixed tick rate. This is a number we will use elsewhere. Over, unload, on continue, ready. Okay. So we go to our prepare game services. Yeah. A lot of that I'm not thrilled with, but okay. This is okay, so these are still in the resource file, and these are relevant accordingly. So I need to get the visual scale. I need to get this particular shader out. We're setting up our collision manager object here. Notably, see how I've instantiated it and then said it's collision scale? I'm not using those anywhere. I think this is entirely vestigial. Same here. Just gonna... Let's... Repair game services and services. Oh. Okay, we are going in and saying this one now exists. We are prepping them. We're going to use them in a minute. Yeah. Stats 1. The renderer, the collision manager, the inventory UI. That's puzzling. Okay, we are. Again, this part is something that we do need to deal with. I need to deal with that one quite a bit. Yeah, these are remaining elements that I don't need to have sticking around if I can avoid it. So our entity renderer, let's go find you. Entity node renderer scene. It's less that I don't want it around at all. It's more I don't want it around in that format. If there's a way I can avoid that particular song and dance with it, that will be good. Is in services rendering entity. Individual nodes. Okay, yeah. It does not need to be how it is. So right now we have set up a packed scene. That packed scene is a node 2D. That's it. Everything else is happens after the fact in code. This does not need to be an actual scene. Similarly, the collision manager that we have set up, I don't think needs to be there. Let's... Just gonna science a couple of these here. Make sure collisions are still happening. They should, because we are not using... Yeah. Sky. What are you doing? Yeah. Are you done toasting? He's a big fluffy boy. He also has just long, like, droopy whiskers. Not so much that they're always curved down, it's just that they're not, like... They kind of fan out a little bit. Direction varies based on how he's sitting or, you know, how he has been laying down recently. But really long, prominent whiskers. He also has, they're almost kind of like brow whiskers. Same thing. Same, They're not as heavy as the ones on the muzzle, but they're kind of kind of the inner side of the eyebrows or that region. He also has additional whiskers. Same level of sensitivity and whatnot. He really likes to have like the side of his chin scratched or his ears or similar, but like a lot of cats, his whiskers are sensitive as far as being brushed, and because they're so long, it's easy for them to bump into things. So it's helping him essentially show you how he wants to be pet so that it doesn't bug him. Wearing my arm out here, though. Okay. We're going to pull that. Hide that. We don't need to keep updating that. Come here, you. Oof. They're heavy. Limbs are starting to jam up a little bit. You can't hear it, but there is always like a... If I rotate my wrists much at all, there is an audible cracking and popping sound. The joints. All right, so we go through, we prepare the game services. That's what we were ultimately looking at there. Now we are going to... We're storing these off locally. We don't need to do this anymore because these are all known entities. We can get them when we need them. Hello, Sky. Yes, hello. He wants a hug. He does. He is standing his hind legs on my thighs here so that he can drape his forepaws up onto my collarbone. And if I ignore him, he will stand on his tippy toes so he can headbutt me. Yeah. If he gets enough attention when he's like this, the next thing he's going to do is he'll kind of flop to the side so that I have to hold him in the crook of my arm like a baby. Because he's a big baby, yeah. Yeah. There. Uh-huh. The camera is currently on Ember, who is snoozing away in one of her favorite spots. Originally, that was pretty much her spot. That was... She'd go there. Sky would occasionally go over there and try to snuggle. Ember is a sweetheart to people, but she's kind of standoffish with a lot of the other cats. She's a real personal space kind of cat. But as time has passed, Sherbet also likes that spot. Molly likes all the spots, in particular that one. And Molly has zero care if there's somebody else there. She's like, I can fit. Oof. Okay. So we don't need those. We should not be storing those off. We are setting up the camera. I do want a camera handler that is a not immediate term thing. AKA the stats layer are the little numbers that I use to keep track of like how many entities there are active currently kind of thing. So we set the level, which is going to result in some other things reacting when that occurs. Yeah. So we tell it, send this message, use this level. Then we are going to So then we're adding the stuff that draws the entities, handles collision, handles the inventory and the health onto the screen. Then we are going to start the level. So currently we are forcing those messages to happen. I don't know if that's the route that we want to have, but there should be something that does that for us. There should be something that we're calling to say, hey, do the thing. We should avoid wherever possible being from outside going in and saying, I am going to poke this and make it emit this message. It's if game were a emits level start and emits level set, that would be different, but it is not. Okay, so now by getting to this point, let's see, then we are going to we add the camera. Okay. Dealing with a cat. Sir? What? I already gave you additional food and lots of attention. So we add the player and we start the level. So upon starting the level, since we have added the camera and the player is loaded, at this point, the game has actually begun. So of everything that we have had up until now, we could say that that's like configuration stuff. That's a build-up that is largely you're kind of in the menus. So there's kind of minor states happening. Which menu am I on? Which message am I sending? But aside from like loading the raw data, most of that stuff is in service of getting to here. We are starting gameplay. Check a couple things here. Buttons, buttons, buttons. Button there. Button there. Button here. Okay. Okay, so now we're in this and we are looking at, we have process and we have physics process are going to be our core little bits. So we're going to look at process first because it's lightweight. It is not actually more relevant or that it even happens before the other, but this one's lighter, so. This says camera handler. It's not really a handler. We need a... I want the entirety of camera to be its own thing that I load in. If for no other reason than in debugging purposes, I don't want to be actively like in the game loop saying, here is now a camera. It is, there is a camera handler object. It is activated and added to the scene kind of stuff. A do what you gotta do kind of entity. But update the camera is where is the player, where should the camera be, that kind of stuff is going to be happening. If I ever have it where the camera needs to pan over to a point of interest, that's another reason that the camera handler should be its own thing, because then we can have events that are, you are tracking the player, you are watching this spot for this much longer, kind of scripted sequences that can be happening such that there isn't just a camera entity floating around that the core gameplay loop is looking at directly. Okay, then we do physics process here. And in physics process, okay, so we have our game start, game time passed, game end. I'm sorry, game end, game steps done, and then we update the debug. So So we are beginning the game steps. This is a step that is the beginning of the loop. We have some amount of time has passed. This is kind of Godot level time passing. So as fast as we get physics ticks, game time is passing. Then we get an end step. This is we are done with the formal steps. Anything that happens at the end should happen now. Then game steps done is meant to be a confirmation that this whole loop is complete. These the difficulty with this part is we ended up implementing this because we're done for real this time. So these should always be things that are, if I do this, it doesn't matter the order that I react to it. So nothing in game start step, anything that listens to this should not care if anything else ever heard it. Same with time passed, same with end step. But it's okay if their actions affect other stuff. Game steps done should be nothing new enters it. This should all be, we are preparing for the next stage. So this is as much a so each of these is a step state, or a larger scale like step. I'm beginning this process. I'm telling everything that time has passed. I'm done with this process. Now we're done with the physics step. That's what this is doing, is we're done with that step. Or I'm sorry, we're done with physics process. A whole game cycle has ended. Each of these within them will have other steps, but this is a major state step here. Because there could be any number of other things we're doing after this, but this is saying this whole block is over. This is as much an opportunity for us to hand off to the next thing and say, you're in charge now. You have received control. You do your thing. So I think this is one of our first opportunities to look at the state flow and say, all right, I did these steps. Now who's next in line for control? These represent state changes as well, but in their own way. Okay, so now we're going to be looking for what is looking for a game time passed, a game start step. This is where things get fuzzy. So like this is a physics start. This is another reason that we need to be looking into stuff, because these start step messages, well, there's a vagary in here, and I need to make sure that these messages actually contain relevant information for me to be passing them around the way we are. World start step. This isn't going to be the perfect way to find them, but... yeah. So here's a good example of this. The collision manager is looking at this and saying, on game start step, I have something to do. Do I really want it to be that it is the collision manager reacting to this message, or is there a stage in the flow where I say, okay, it's collision handling time, do the collision thing? And we effectively formally hand control to the next thing in the sequence. Because this is desynced. This is, I have no control over what order this occurs in. Or will the physics system get this start step message before something else? I don't know. And this is also only the shader collision manager that is doing this. It is the only one that does that. To see if this emits any sort of messages real quick. Yeah, it will invoke physics done during this process. All right, so on game start step in the shader collision manager. So if we are actively computing, what we are going to do is get the results. This is one of our problems here. It is possible it's not done yet. If it's not done yet, doing this might artificially truncate it and not give us all of the collision results that we expect. This creates uncertainty. We don't like that. So we're pulling the results. We get all of the collisions, send them to entities. So if we are not computing, then we're going to say the physics is done at this stage. And for physics done, we have base world state does this. Physics server collision manager is not what we're using anymore, so I'm not worried about it doing things. Entity position buffer we already know is not what we want. Okay. So then base world state on physics done just sets a flag. So this is another example, is once physics is done, we are ready to move on to the next world state. Until physics is done, we can't do the next simulation step. We're still waiting for things to bounce into other things. Okay, so then game time passed in base world state. We're just going to call it work within fixed tick. This is the accumulated delta. It needs to be at least the fixed tick rate. If enough time has passed, we are going to call it all the way down until that we don't have enough for another step yet. So again, it's no matter how fast time is going outside of the world state, it will only ever move in increments of fixed tick rate, which is right now 1/30th of a second based on the configuration. It can be whatever I want it to be. But it's, if the processor is going super fast, it doesn't matter. It will be 1/30th of a second. If the processor is going super slow, then what will happen is that every time an update is allowed to happen, it will only be as if 1/30th of a second passed. This is to try to reduce the possibility as much as possible that you get timing-based physics aberrations. I showed you one earlier where an enemy managed to walk through a wall. You can normally avoid that kind of thing just using delta time, which is already what we're talking about. What we have here is the engine saying this many fractions of a second have passed since the last time I asked you what's happening. By using that time slice, you can make it so that we're processing at a very granular level based on how much time has passed instead of processing based on how many times you ask me. It's why old DOS games go berserk on new computers, because they didn't use a delta kind of concept. They used every time the processor gets around to asking me, stuff gets to happen. Apparently, King's Quest speedruns, like the old ones, speedruns of that are as much about memorizing where the collision surfaces are in the world, because and how long you need to press a direction key. Because for the most part, when you move in that game world with the processing set to the right, there's a particular set of values for the processing that essentially unbounds it. So just tapping and the time it takes to tap the arrow key, the character will probably sprint and keep sprinting in the same direction until they slam into a wall. It is not about navigating the map. It is about finding hard surfaces to slam into. This kind of logic prevents that. If you're dealing with like platformers and walls and whatnot, if you don't handle this correctly, it is frequently possible for the character to run through a wall. Because if enough time has passed, if the delta gets big enough, or if we're processing it, if the character is moving too quickly, or both, then what can happen is that the object in space will have moved far enough that it gets past the collision surface. There are physics tools that you can use in things like Godot that will do they will see if I move this way, find out where I collide and stop me there. But we don't want to stop in the middle of the collision. I don't want to do another collision check in reaction to that right now. There's more to the simulation going on. But if we were just dealing with, say, kind of a precision platformer, your Mario kind of games, then that kind of collision handling can be plenty. It's I jumped, I hit something, okay, we're going to trigger the knockback and we're going to trigger damage. But that doesn't work for everything and in every circumstance, so you still need to be cognizant of this kind of movement difficulty. Anyhow, we're checking pause logic, but if we are paused, that is a particular state. It's in our purposes, we're not actually paused. We're on a different, we're in a different state. And this is something that we can handle in that is the world step is a state. I am in the middle of handling that. When I am done with a world step, it is possible that the next thing that takes control is the inventory screen. And the inventory screen doesn't care about things like the world start message and similar. It's more interested in inventory manipulation. So everything that would be happening in the background otherwise is not happening anymore. With caveats and a lot of difficulty, but put another way, pause should not be just a flag. It should be a state relevant to what you're actually doing. The world is not stopped because I have set the pause flag. The world has stopped because something else is in command right now. And there can be multiple simultaneous states, but for our purposes, we are talking about it as if there is a current single command state, Okay, so we have world start, world time pass, world end, world step stop. Then within each of these, might just need to have world start, but okay. So we have the entity manager has one of these. Just the entity manager listens to world start step. And what that is going to do is it's going to do its entity update. Which we are going to remove some of them. This is any that are out of bounds get removed, and any that are in the list get removed. Uh, it's not that we need to remove them because they're out of bounds in general. It's we need to have logic that acknowledges, like, if a bullet is too far away, it doesn't need to keep going. But even that isn't really what we're looking to do. There should never be something that lives forever in the game. And the only reason we need to do the out of bounds to remove them check is if there is something that is effectively living too long and it's eating performance by existing. That should not be happening anyhow. But then we remove entities that are queued for removal. Hooray. Then we're going to look at world time past. And let's see, base inventory has one of those. There we go. Okay. Base player state has one. Base inventory has one. Okay, so base inventory should have an on world time past. This is kind of weapon handling here. It's going to be a whole other ball of wax as well, is how we're handling the special spawners that are weapons. Those have definitely been accreted to a tangible extent here. We do need... That definitely needs a review and scrub down. We'll see. We'll get there. So then we also want the one that is in base player state. That is iframe handling. In entity. This is another one that I have concerns about. Yeah, okay. Okay, so we did, by implementing it this way, we did clean some elements up, but I feel like we may have, not going to say baby with the bathwater, but it's in... as far as like sayings go, it's in the same neighborhood. You know, it shares a zip code. We moved this over to the event model when I don't know that we should have. So what the entity does when this happens is that it relays time passed to all of its behaviors. It is good that we're getting that message cleanly to the entities. But we have essentially removed any control over the sequencing of it or any control outside of the entity. So we do need to make sure that we're doing this. It is possible that we want to do it this way, but we may want to return to the idea that the entities are not handling time passed themselves, but they are being relayed time passed by something else. So maybe the entity manager will handle time passed, and it will send that, relay a message along to all of the active entities. Maybe we'll do that again. We'll see. But I have concerns that by putting it in each entity itself, we are creating a real gray zone as far as exactly when is this happening. Might need to, at the very least, we might need to wrap this part in a state again. It's entities are acting now. Is a thing that is occurring. Entity. Okay, and then back up here we have world end step. So entity again has world end step. And in that one, okay, this is our position, which animation we're using, that kind of thing. So again, we have emitted this message. Every individual entity gets this message and reacts to it. The exact way we send that message out is not the concern. It may just be that we don't want it to be that all entities individually get this message. No matter what, we're still iterating over a series of events. We're iterating over every entity and calling a function. That is still going to happen. We might not change the fact that it is the entities that house the code and the reaction to that message, but there may be a sort of period in the code where we say this is the world end step. It is not that there is a change in the actual code being executed. It's that all of this is happening inside of this particular bubble. If nothing else, if we get nothing else out of this, one of the things that we can do is set up debugging flags so that we know what is happening and how long it is taking within each of these segments. Okay, entity is the only one that cares about world end state. So now world steps done is the next thing. And we have shader collision manager in here. And in that one, So this is something that we'll have to look into is, should the physics start message be happening, one, at the beginning of this process? Like, physics isn't really happening unless we start computing. If we haven't started computing, physics is still happening. It is not that it starts and then maybe it will actually start. It is that if computing is happening, physics is still happening. If computing is not happening, physics can now start. So again, another opportunity for us to look at this, because if I am in a step where I get to this and I am not computing, then physics is starting. If I get to this and I am computing, how? Like, from a flow perspective, if I'm still computing and I get to this, that means I have done a world end step. But that everything to get to that point, the world step's done, everything to get to that point must not have happened because physics is still being calculated. I can't do a fresh one. I can't have done any of those if the prior physics step isn't done yet. So there was a whole bunch of, I'm not really ready yet, skip these, that must have been happening up until that point. Okay. Then let's see here. We're going to go back all the way up to game. And step plus equals. Nobody cares about this one. Steps done. This is an indication that I have over-engineered a bit. Shocking, I know. But I have no listeners on those. That means no code reacts when I send those messages. I could, but their presence implies that I had some reason to put them there. I don't remember it, and it's not evident in the code. So, I don't know if you've ever encountered this. There's a very particularly morbid way that you refer to process documentation and disaster recovery planning. And that's the hit by a bus question. Is, what would happen if so-and-so was hit by a bus tomorrow? When it comes to how things happen at a job or in a system. Because there are plenty of places where the answer to what happens in this circumstance is, oh, Newt will do that. Or what happens if this breaks down? Oh, Newt knows how to fix that. What if Newt is hit by a bus tomorrow? There is a particular, there's a particular expression of panic that I have managed to get out of people by asking them that question. Because the answer to that is everybody will have to panic and root around in the code to figure it out. So if nothing bad can happen like that, so, okay, well, what happens if nobody knows right now in the code? Not a problem, big deal. But if later I came down, I was moving around and I said, oh, well, I'm just going to do this because this will make it so, or because I don't know that there are no listeners. If I assume that there are no listeners, I could remove that and everything is fine. If I assume that there are listeners and I leave it there, okay, again, no harm. But it is possible that because it's still there, later in code, I do stuff that makes these irrelevant. They're not supposed to be used anymore. We don't do those anymore. But other code could try to use them because there is code implying these do things. They are present. They are things that could be emitted. So I could have code that tries to listen to them, and then nothing will happen. Or even worse, they are vestigial in that they're still there. They operate like they used to, but you're not supposed to treat them as if they work the way that they used to. Like, game steps done if nothing's listening to it and I leave it there and it ceases to be called at the time that is the equivalent of what game steps done used to be in the logic, I now have a problem. Because if new code is written that assumes that's going to happen there, things could start to get weird. And just as bad, if not, well, worst case, it doesn't look like it's broken. It looks like it's working. That's how you get the bad bugs. Is it's written as if it should work that way. It is undocumented that it doesn't work that way. It looks like it works that way when you try to use it. It doesn't actually work that way in practice. You will find that kind of thing all over official documentation. It says it's supposed to work that way. It doesn't work that way. It very much doesn't work that way. And the only way to find out is digging around in forums. For example, I mentioned this earlier, but where are you hiding? Sync. This guy. Documentation implies that if I call this, we will block right here. We will wait on this call until the GPU finishes the compute shader, and then we retrieve the data. That's wrong. What happens is, I think it probably gives it like a breath or two to finish what it's doing, and if it doesn't, it's done. You're done. You're out of time. Give me the data that you have. This is our collision. We can't have that. And even then, it's if I had to block and wait a really long time for that, I can set up code to allow that to work. But the fact that it might randomly truncate it, that's a problem. I can't do that. There are other functions that are documented to do things that I could use to mitigate that problem, but they don't work the way that they're documented. So, put another way, I want to set this up so that we are shielded against some more of this nonsense, that we can we can engineer around it so that if we find problems, we can actually go in and say, during this step, this is when we have the big performance bottleneck. How can we either add intermediate steps or adjust this step? Okay, so what have we accomplished today? I wrote a bunch of things in a notepad. Notable things. Our core gameplay loop. We are redefined here. The goal is enter the room, knock out the baddies, move to another room. These are the three core functions that say if the game is doing this, we have the bones of the game. We have the currently we have the ability to enter a room, and we have the ability to knock out enemies. We don't have a structure for moving to another room. There are other goals in this to make it the game that we want, but if we can get those things, it then comes down to more iteration. Additionally, our entities goal, we have now set a discrete, I want it to be 60 frames a second with 2,000 things on the screen at once. We are not there currently, but this is much more achievable than where we were previously. This will require some performance improvement. I'm fine if it is sharper drop off after that point, because we've already done optimizations to mitigate the idea that the game will break down, like that the logic will break down after that point. But by setting this as our target number, it means that we can also build like power-ups and whatnot to account for it. It gives us a, like, hey, we can't have too many triplers because, you know, past a particular number of powers of 3, the numbers get pretty big. But we've gone through, we've defined what our basic code flow is, and for some of these to-dos, we have found places that we can look at for cleanup, like the resource file objects. Those are some good targets for a stream of actual code change. But also things like these where it is, let's start looking at the flow, and instead of it just being those messages, look at it from a perspective of what is now happening. Like, it's not just that the actual object that manages the world has control, or is the one that is currently processing a message. It's that the whole system is now saying it is now the time that we are processing the world logic. It is now the time that we are processing the physics logic. And there could be like stacked things, like we're doing both of these at the same time, or both of these are true, you know? But we want to then start looking at those states. Where are we at? Right now, we have the idea of, I'm doing overall system maintenance steps. So we are in the game step, where we're looking at it and saying, should I shut down the game? Do I need to, well, at the moment it's, do I need to update debug information? Should I shut down the game and update the camera? Camera shouldn't really be there. There's, okay, we have handed off to the world now. We're doing the world steps. Okay, world steps are happening. At some point at the end of the world steps, we're going to say, okay, all this world stuff happened. Let's do the physics stuff. Okay, we're doing physics stuff. If I'm in the middle of doing physics stuff, which states can also happen? So this is the states could be simultaneous. So the game steps where I'm updating camera and similar, that might still be okay to be doing during the physics stuff. Might there be nuance to that? Yes. But for the time being, we're going to do it as linear, is I'm updating the physics stuff. Until the physics stuff is done, I can't do other things. If we can get that series of steps done and we put brackets and some telemetry around them, have I been using that word right? Anyhow, then we can also start to refine it down to understanding where are the costs happening. Because I can hyper optimize a step all I want, but if I have been, even if I've been in the right area, if I've been focusing on the wrong part of the process, I might be getting smaller gains when I could be getting much bigger ones looking somewhere else. Because we're definitely past the stage where I can look at it and say, oh man, all my time is being spent in the physics process step. That doesn't help me, I know that. Oh, it's being handled in these script, in these function calls. Yeah, I know, it's all being handled in handle message. That doesn't help me. Okay, though. Yeah. I think this will be a start, and it does give us this idea of which things are relevant, but because end step and steps done aren't being really used, what we've got is, this is a maintenance step. Like right here, the only reason that I have the game start step being done the way it is because of the way that the physics is being processed, that we have to get it at the top of the next physics tick. But I don't. If I'm in physics mode until physics is done, I'm in physics mode. Then when I get the tick, when it comes back around to the tick again, I'm in physics mode. It does physics stuff. And we keep passing that along. The physics step is one that does not relay along until a whole loop has happened. So we would be doing the game step stuff, again, kind of clerical work kind of stuff, like administrative work. Then we do the world step. So we're passing time to the behaviors, all of that stuff. Then we get to the end of that and we say, okay, it's physics time. The physics handler does not pass its control along until it gets another physics process tick. Put another way, there is an entity in between here that is the current state. There is the current control. That one is the one that's getting that physics tick, the little time slice that's coming in. When the game step gets it, it's like, oh, okay, I'm just going to do this cleanup work here. If it hands off control, it's going to be to the world step. World step gets control, gets the same delta tick, and says, oh, okay, I'm going to do these things. Because a transition in control happened. So what we're probably going to have is the idea of, again, state isn't necessarily the best word, because there are a lot of, it's both generic and specific to various sorts of coding patterns. But we have a physics process tick with a delta. We have a current state. That delta goes to the current state. The current state does things. Current state might trigger the next state to happen. If that does, that state takes control and it is given the current delta, and so on and so on and so on. If it does not yield control to something else, or if we're out of things that get passed along, then it loops back around and we go to the next physics tick. This can happen as often as it needs to. It also means that we have plenty of opportunity to say, I'm not done with this step. Do not yield. As it goes along, we could accumulate like layers and stacks of states to deal with. It's not a perfect analog, but this kind of thing is referred to as a state machine. We'll see how well it holds to that, but that's for next time. That's for next time. Oh, and that will be a good starting point, a stopping point for today and a starting point for next time. Now, we do intend to have the coding streams at least once a week, if not twice a week. Goal is still 4 streams for the week. We'll see if we get there. I do have the next coding stream prepped. I don't know what the next game stream is going to be. We'll figure out something. We'll get that in place, and we're going to try to have fully scheduled out streams again. I want to get to the point where we have, where I have some hope that, we will hit a schedule, because there are some things that I want to do that necessitate that I'm not going to flake out on you. But yeah. But everybody had a good time. This was a pretty dry one. This was a lot of, here's some code, listen to me monologue. But I hope it was educational, if not interesting. Or both. Anyway. But I hope you had a good time with us tonight. If you like what you saw and would like to see more, remember to like, follow, subscribe, comment. All those buttons down there are generally good things, and they help the channel. So I'd appreciate it if you press them. If you'd like to consider supporting the channel financially, you can do so through platform-specific means, as well as other options available through the LinkTree links in the description and bio. With that said, though, I hope the rest of your day is good, and I will see you next time.